Dear students, I welcome you all in my lecture series on communication electronics. Basically, this lecture series is designed to meet the requirement of the UG students who are studying in second year of this university and who have opted electronics as their one of the subject. But the video lecture is also helpful for the students of MSc who are studying electronics as a subject, for the students of BSc Physics whose one of the module of the course of electronics is dedicated to communication, and this is also helpful for MSc Physics people who are doing a specialization in electronics. So I am designing this lecture keeping the requirement of all these viewers, but my main focus will be the syllabus of BSc second year electronics. The communication electronics is one of the paper of this year. The book that I will refer are Principles of Communication System by Taub and Sealing, and Modern Digital and Analog Communication System by B.P. Lathi, Electronic Communication System by George Kennedy. And since 2 units of the syllabus are dedicated, one unit is dedicated to television system and other unit is dedicated to radar system, therefore I have written 2 books in my references for these 2 units. For television system, the book written by R.R. Gulati, that is Monochrome and Color Television by R.R. Gulati, published by New Age International, and Introduction to Radar System by M.I. Skolnick. And for modulation and demodulation purpose, various kind of modulation and demodulation and radio receivers, transmitters, most of the time I will refer this book, and for some problems, for some explanation, I will refer this book and this book also. So you can have any one among this 1, 2, 3. You can have this one or this one, and you can have this or this. This will be sufficient for your purpose. Now, first of all, I would like to explain the meaning of communication. Communication in general, and then I will come to explain, later on I will explain the electronic communication. What is the meaning, what is the purpose of electronic communication? Communication in general involve only 3 units. That is, suppose if you are sitting just in front of me at the distance of say 2 meters, and we are making conversation with each other, this is also the simplest form of communication that we are doing. Here I am the message source, or sometimes you may be the message source, I may be the receiver. But suppose if I am talking to you, if I am saying something to you, then I am the message source, or simply saying I am the source and you are the receiver in terms of communication terminology. And my messages, whatever messages I have generated, M stands for message, is going to you, to your ears, through a channel, through a way which is known as channel, and here air is the medium, therefore air is the channel. This is the simplest possible example of a communication system, but this can stand good or hold good for a short distance communication. This kind of communication can be done only if the receiver and source, they come in the audible range, maximum up to 10 to 20 feet or maximum up to 10 to 20 meters. Now suppose if we are talking to establish communication, somebody started loud music at the same place where we are doing our communication. That music may be a desired signal or maybe a desired item for him, for that person who desires to listen music, but it is an undesired signal for us. Therefore it comes under the category of noise for us. This is a noise, means any undesired signal is noise in a communication system. Now suppose if you are not just sitting 2 meters away from me, but you are sitting in Delhi and I am here in Gorakhpur, and you are somewhere in Delhi, and we want to establish communication between us, we want to have a conversation between us, then what is the way? Then somehow I have to convert my voice, my speech to electrical signal, and that electrical signal is fed to some means. Say I wish to communicate through telephone, then naturally my voice or information. Now I am moving my discussion towards electronic communication, means long distance communication. So first of all there will be information source, and then there will be the destination. I am the information source in this situation and you are the destination where information has to reach. So this source generates information, this is destination. Here my voice or my speech is information, my sound is information, but that has to be converted to equivalent electrical signal through a device which is known as input transducer. Input transducer. Now after this electrical conversion, it has to be converted, further converted, or in a very particular term it should be modulated so that we can make it suitable for radiation, for transmission. So the total block which is used to make this, now this signal which is the output of this transducer is called input electrical signal, but this signal has to be translated to a form which is suitable for broadcast, and this transmitter is responsible to make it in that form, and then the things are transmitted on a channel. Channel is simply a link through which processed information can propagate from transmitter end to receiver end. And then finally the broadcast information is simply tuned by a receiver system. Receiver system further demodulates it, and they are then fed to the output transducer, maybe a speaker in this situation, and then the destination or the final person who is willing to listen my speech or my sound comes in picture. So this is the total block diagram of a communication system, but we have still left one block over here. Here noise or undesired signal or distortion is added. Noise or distortion is added. Although it is shown over here that noise is added at the channel end of the total communication system, but this is not true. Noise is added at each and every block or each and every part of this communication system. Noise can be added at the source point also, at the input transducer point also. A very big amount of noise is added at the transmitter end. While traveling from transmitter to receiver, variety of noises are added. Noise are also generated by receiver, output transducer. So each and every part contribute few or more amount of noise to the overall communication system. Or one can say that the noise is the biggest enemy of total communication system. Now I will define each and every block. So what is source? Basically source originates a message. Source is a place where message originates, or source originates a message. It may be a picture, it may be a video, it may be some data communication messages, or it may be a voice, that is the classical message to discuss. Then we have input transducer. So input transducer is a system which converts the source information into an equivalent electrical waveform. It converts the source message into an equivalent electrical form. Now transmitter modifies this equivalent electrical form of the source message is known as base band signal. This electrical form of source message is known as baseband signal. Since these terms will be used very frequently later on in my lecture, so they should be clearly defined at this point of time. And so transmitter is the section which modifies the baseband signal for efficient transmission. So transmitter incorporates many parts in it. What are the parts of transmitter? If we expand this single block, transmitter can further be broken and can be viewed in many parts, many subsystems rather. It consists of, first of all, pre-emphasizer. Sampler, quantizer, then there will be a coder, then there will be a modulator. So these are the some parts of this transmitter. Basically these parts, sampler, quantizer and coder, they are needed in case of digital communication. Here for analog communication we need only pre-emphasizer, modulator, like part. Similarly at the receiver end, this block receiver is also made up of many subsystems, and those subsystems are demodulator, decoder, filter, and then de-emphasizer. These are the subsystems of this receiver block. Basically what receiver does, the receiver processes the signal received from the channel by undoing the signal modifications made at the transmitter and the channel. So basically it undoes the process of modulation and brings back the signal to its original baseband, and destination is the place where message has to be communicated. This is the overall block diagram of a communication system. Basically a term is coming over here, that is modulation. Firstly I will tell you how many kinds of modulation we will deal with, and then I will define and explain what is the meaning of this term modulation. Broadly speaking, this modulation can be classified in two ways. Rather, analog and digital. In terms of analog and digital communication, rather, Now this analog modulation can be further divided into amplitude modulation, then angle modulation, and then pulse modulation. Pulse modulation also comes under the category of analog modulation. Digital modulation is a separate stream which will be discussed in the lecture series of PG course. Here we shall focus our attention only on analog communication and analog communication systems. So amplitude modulation can have many forms. One form is double sideband full carrier. In this scheme, both the sidebands and carrier together with sideband is transmitted. Then we have double sideband suppressed carrier, in which both of the sidebands are transmitted but carrier is suppressed. Then there is single sideband suppressed carrier scheme. In this scheme, only one of the sideband of the double sideband is used for transmission and other sideband is suppressed and carrier is also suppressed to save the power transmitted over the channel. And then we have vestigial sideband. We will study in very detail about all these schemes later on. Here simply I am drawing the boundary of our study, from where we have to start and which zone we have to remain confined. Then the angle modulation. Angle modulation is basically of two kinds. One is frequency modulation and other is phase modulation. So we will also study the generation of FM, PM and their demodulation. We will go through the generation of all these systems and their demodulation demodulators. And then there are pulse modulators. Pulse modulators are also the pulse width modulation, pulse position modulation and pulse amplitude modulation. In this modulation scheme, a pulse is modulated or changed according to the baseband signal. In one of the scheme, the width of the pulse is changed. In one of the scheme, the position of the pulse is changed, and in this scheme, amplitude of the pulse is changed according to the baseband signal. So these are the modulation schemes that we have to go through our study. Now I will define the term modulation and why modulation is needed at all. Rather, we will see the term modulation and then we will see the need of modulation, why modulation is needed at all. Basically, we have two signals in our long distance communication purposes. One is called message signal or baseband signal. This is basically indicated by MT in some literature, VMT or whatever notation you give it, and for the sake of for the ease of discussion, it is taken as single frequency sinusoid, low frequency sinusoid. Say we take it Em cos omega nt. So this is the signal which has to be communicated. Then second signal is called carrier signal. This is a very high frequency signal, VCT. It is written as VCT and it is equal to EC cos omega CT. Here the situation is omega C should be very higher than omega n. What are its benefit? We will see it later. And this signal, high frequency signal, is known as carrier signal. Just if we incorporate some initial phase to this equation, we will get this equation like this. As you are looking that this carrier has two variable parts. One is its amplitude and another is its angle. You may say it frequency or phase. One is related with other. So this amplitude can be varied in accordance with the baseband signal, or this angle can be varied in accordance with the baseband signal. In this situation we obtain a kind of modulation which is known as AM, and in this situation we obtain a kind of modulation which is known as angle modulation, which can further be divided into phase modulation and frequency modulation. But still the term modulation remains unanswered, and I will explain it to you by giving an example. Suppose if I wish to throw a piece of paper on which some letter is written to a long distance. If I simply fold that piece of paper and make an attempt to throw it, it will hardly go to 10 feet, 20 feet, and not more than this. Suppose this is the piece of paper over which something is written and I wish to simply throw it. It will go hardly to 20 feet distance. But suppose if I wrap it around a stone, say around a stone whose weight is 200 gram, and if I simply fold it and simply by a rubber band, simply suppose if I bound it and I throw it, then it may go to 200 meter. So now this piece of stone is acting as a carrier for this letter. Now if the person who wishes to receive this letter, he will simply unpack this piece of stone from this letter piece, and he will read the content of letter. So for here, in fact, we are doing a kind of modulation. This stone is acting like a carrier and this letter is a message signal. To establish a long distance travel of this letter, we are simply imposing this letter over a carrier. We are throwing it and then we are detaching this carrier. At the receiver end, we are detaching this carrier, means stone, from the message. Same thing is done for the long distance communication. For the long distance communication, we impose the weak message signal on a high frequency signal which is known as carrier, and this process is known as modulation. This is the very basic definition of modulation. And okay, let us understand it with another example. Suppose if we are viewing a say cricket match, a day night cricket match in a stadium, and the captain of field, the captain who has decided to field, wish to put his player at proper position. What will he do? He will wave his hand to position his fellow players. This is a day night match, and it is say 8 p.m. of night. So simply by waving his hand in certain gesture, he is putting his fellow player at the desired position. Now, what is signal over here? In this situation, waving his hand in certain gesture is signal. What is carrier over here? Light that is on for the day night matches is carrier in this situation, and this hand waving is imposed on the carrier, and this way the receiver means fellow player is getting signal what to do and where to stand for. So basically signal and carrier both are required for modulation to be there. Now I am imagining a situation. Suppose if I wish to transmit the signal without modulation to a high frequency carrier, then what will happen? What difficulties will come in the picture? The human, if we look at the frequency spectrum of human speech, of human sound, magnitude at a particular frequency m omega, this picture comes something like this. Means it starts somewhere from 50 hertz and it goes to 3.3 kilohertz. Suppose if we wish to radiate it through an antenna without modulation, and simply we make this calculation for the frequency of say 1000 hertz, that what dimension of antenna is required, in fact it will come out to be around this much meter. This much meter length antenna is required. So you think whether it is possible to arrange an antenna of this much dimension? This is impractical. But suppose if somehow I shift this signal from this lower frequency to some very high frequency, say here it is 10 is to the power 6 hertz, and instead of this baseband, this signal is translated to this frequency range, means 10 is to the power 6 hertz plus 3.3 rather this much plus this frequency, sorry, its maximum frequency will be this. So you see, if we divide the maximum frequency by minimum frequency, okay, this is all right, 1003300 over so it will be 1 point something 1.033 like this. But you see, now the antenna dimension is drastically reduced. Basically, the length of antenna required should be of the order of lambda by 4, the wavelength that we are transmitting. It should be about 1 by 4th of the wavelength. Here in this situation, wavelength is very high. The length of the wave is very high, and therefore the antenna dimension coming to be this. And here in this situation, if it is translated to high frequency, the antenna dimension is drastically reduced, and it becomes very practical to mount an antenna of this size. So for this purpose, modulation is needed, and there are few more purposes for which modulation is needed. This way, modulation makes the antenna length practical. It helps in making antenna length practical. Now suppose if without modulation one wishes to communicate, so in a certain city we have many radio stations. Suppose this is station number 1, wish to communicate at the baseband. Then there is, say, station number 2, wishes to communicate at the baseband, and then say station number 3 is also willing to communicate on the same baseband. They all made their arrangement and radiated their signal, but what will happen at the receiver end? Since all the signals are found at the same frequency range, it will be difficult for receiver or impossible for receiver to distinguish between S2, S1 and S3. So this way all the signals will be mixed, and it will not be possible to hear the signal distinctly. And this kind of scene is called frequency chirping. This is called frequency chirping. Just to get rid of this, what we do in modulation, we assign a separate carrier frequency for this signal S3. Suppose FC3, carrier signal, this signal S3 is modulated with carrier signal having frequency FC3, and this signal S2 is modulated with carrier signal having frequency, say, FC2, and this signal S1 is modulated with carrier having frequency FC1. Then they take different places on this frequency band after modulation. So suppose this FC1 is here, so this signal 1 after modulation is translated over here. Then FC2 is here, this signal 2 is after modulation, it is translated over here. Then this signal carrier FC3 is over here, so this signal S3 is after modulation taking its place over here. So for the purpose of demodulation, it becomes very easier to distinguish between these signal, and this scheme of placing various signal on the same frequency band is known as frequency division multiplexing. Frequency division multiplexing. So by frequency division multiplexing, we can send many signals on the same frequency band. Using the same frequency band, we can communicate many signals. So these are the some benefits of modulation. I think I should stop this lecture over here, and in the next lecture I will explain a detail about the amplitude modulation and generation of amplitude modulated signal. Thanks for listening. Thank you.